And welcome back. So we ended the last video asking the question, how do we solve 12 to the x power makes 10? And that's going to be at the core of this next unit, really. How do we undo exponentials? And yes, by the way, that 12 to the x power is an example of an exponential equation. Anytime you've got something you don't know as an exponent, that's your exponential equation. If your unknown is the base, but you do know the exponent, that's not really an exponential equation. That's just a polynomial, that's old hat. But when the unknown is in the exponent, you're looking at an exponential equation. Now, those you can't undo, right? You can't get at this x here for 12 to the x power by taking a root. That's how you could do x to the 12th, but not 12 to the x. We can't divide, we can't multiply. The way we undo exponential equations is with their inverse, which we will call a logarithm, which is a fancy word for a very simple concept. Just some quick examples here. If I want to solve this exponential equation, 3 to the x equals 81, or if I want to solve 3 to the y equals 1 over 9, in both instances, I am asking myself this question. 3 raised to what power gives me 81? Or 3 raised to what power gives me 1 over 9? And there's no hard and fast arithmetic we have to do here. We can just kind of stare at it until we figure it out here, right? 3 times 3 is 9, times 3 times 3 is 81. So 3 to the fourth power gives me 81. So x here has to be 4 because 3 to the fourth power is 81. By a similar stroke, y has to be negative 2, right? Remember that exponent rule we talked about at the start of the semester? Negative exponents means reciprocal. So here, 3 to the negative second gives me 1 over 9. And that's what we mean when we talk about exponents. In fact, that's what we mean when we talk about logarithms. In fact, the logarithmic statement and the exponential statement talk about the exact same things. So this slide here really illustrates the similarities between the exponential equation and the logarithmic form of that exact same equation, right? 3 to the x equals 81 is asking 3 raised to what power gives me 81. In logarithm form, that's what this says as well. 3 raised to what power gives me 81? 3 raised to what power gives me 1 over 9? Same here. Finally, I've got one more for you here. 4 raised to what power gives me 64? Well, 4 to the third. So 4 to the third power is 64. And in logarithmic form, the way we write that is the logarithm base 4 of 64 is 3. And this statement is true because this statement is true. They are just different ways of describing the same information. It looks like a lot, but really what you want to keep to heart right now is this word-based question. 3 raised to what power, or my base, whatever my base is, raised to what power gives me these numbers here. Gives me these numbers here. And that's what you're going to want to keep in mind here. Really, logarithms talk a very specific way. They're slightly different than the way you're used to talking about exponentials, but they're very similar, right? You got some base, you got your argument, that's what's going into your logarithm, and then your answer is what's coming out. So for instance, log base 5 of 25 is 2, right? Because 5's my base, and I want to know, what do I raise 5 to in order to get 25, right? The base raised to what power gives me this argument, gives me that input. So because 5 to the second is 25, there we go. Similarly, if I wanted to do the log base 16 of 4, I am asking 16 raised to what power gives me 0.5, gives me 4. And 16 to the 0.5, 16 to the 1/2 power, oh yeah, square root. Square root of 16 is 4. Just another recollection there. And that's it for our time here. So I just want you guys to read over these, and we'll go over it next one.